This is a presentation of Louisiana Public Broadcasting's Bridging the Gap initiative, supporting distance learning for all students across Louisiana and beyond.
Hi, my name is Mr. Mark, and I'm excited to be your teacher today as we learn more about angles. Now, last episode, we left you with some work to do, and I'd like to take a look at that work now. Point F is on line CD. Find the measure of angle CFE. Then, angle SPR and angle RPQ are complementary. Find the measure of angle RPQ. Let's take some time to look at Lynn's work and compare it to yours. Let's come back together. Lynn subtracted 152 degrees from 180 degrees to get 28 degrees. And then for the second problem, she subtracted 37 degrees from 90 degrees to get 53 degrees. What I really like about Lynn's work is the way that she included precise mathematical vocabulary. It's easy to get supplementary and complementary mixed up, and by writing down the words straight angle and complementary, Lynn took an extra step toward ensuring she is thinking about the right term for each problem. We'll do more work with complementary and supplementary angles in this episode. You will need these materials today: a notebook and a pen or pencil, or a whiteboard and marker. You will want a ruler or a straight edge. Even a piece of scrap paper folded to give a nice crisp edge will work. You might also find it helpful to have a phone handy to take a picture of the screen. Take some time now to gather your materials. We've worked with complementary and supplementary angles already, and we also learned about adjacent angles. Today we're going to use those same vocabulary words to learn about non-adjacent angles and another special pair of angles. In this triangle, we have three angles that are not adjacent. Angle L and angle M do share the same side, but they are not adjacent because they each have a different vertex. Now the problem does tell us that angle L and M are complementary. And so that lets me know that if I add the value of the measures of angle L and angle M, they would add up to 90 degrees. Let's take some time to answer the question. Find the measure of angle L. Let's come back together. We are told that angles L and M are complementary, meaning if you took the sum of their angle measures, you would get 90 degrees. And so 90 degrees minus the angle measure of M, which is 51 degrees, gives you 39. And the measure of angle L then is 39 degrees. Before we wrap up this activity, I want to pause to make another point. Yes, we practiced using the vocabulary term complementary, meaning angle measures add up to 90 degrees, to find the measure of an unknown angle. But another big idea here is that angles L and M are complementary just because their angle measures add up to 90 degrees, even though they are not adjacent angles. Here's another example that would be good to have in your notes. The angle measures 75 degrees and 15 degrees are complementary, regardless of whether they are adjacent angles or not. Let's take some time to get this example in your notes, whether you write it down or take a photo of it and copy it into your notebook later. So we've considered an example involving complementary angles. Now let's take a look at another example involving a straight angle. We don't have to be told complementary or supplementary because we know that a straight angle, or a straight line, has an angle measure of 180 degrees. Let's take some time to find the value of B. Make sure to draw the diagram in your notes first to better support your work. Let's come back together. So there are many different ways that you can approach this problem. Let's see if you could spot your strategy when I chart them up here. So we know that any straight line or straight angle measures up to 180 degrees, and that these three added together add up to 180 degrees. And so one strategy is to take 180 and subtract the other two angles. So minus 95, minus 34, and that gives you 51. Another strategy is to add these two angles up first and then subtract them from 180. So 95 plus 34 gives us 129. And then 180 minus 129 again gives us 51. And yet another strategy is to write an equation. So we could write the equation b plus 95 plus 34 is equal to 180. This simplifies to b plus 129 equals 180. And then again simplifies to b equals 51. Now you might be wondering, wow, that's an awful lot of work to write an equation for a problem like this. But sometimes for complex problems or if you're stuck, it does often helps me to write an equation to help organize my thoughts. Which of these strategies did you use? Is there anything in your work that you would like to revise or add to your notes? The big idea to take away from this activity is that a straight angle measures 180 degrees, and it's not just always two angles that add together and make that straight angle. In this case, we had three different angles that made that straight angle, and when joined together, added up to 180 degrees. Here's another example of angles that add up to form a straight line. We could actually choose several examples here of angles that form a straight line and add up to 180 degrees. Let's take some time and find the angle measures for the unknown angles. Let's come back together. So to find the missing angle measures, I'm going to use what I know about straight angles. And I'm going to start here and see that this line segment makes a straight line or a straight angle and therefore measures 180 degrees. So to find this missing angle measure, I would take 180 degrees minus the 67 minus the 65, and that gives me 48. And so the angle measure for angle CBW is 48 degrees. I'm going to use the same process to find the angle measure for angle WBU, except this time I'm going to use this straight angle here. So again, I have 180 minus 65 minus 48, and that gives me 67. And so this angle is 67 degrees. I'm going to keep going around all the angles around center point B and using the same process. So for this angle, this time I'm using this straight line right here. We have 180 minus 48 minus the 67, and that gives us 65. And finally, this last angle, we're going to use, again, this straight angle right here and say, okay, this is 180 minus the 67 minus this 65, and that again gives me 48. Did you guys notice any patterns? Did you guys notice in this diagram that the angles come in pairs? These pairs of angles have a special name. They're called vertical angles, not in the sense of vertical and horizontal, but in the sense of they are across the same vertex. Take some time now to jot down the definition of vertical angles in your notes. Going back to the pattern we noticed, it appears that our vertical angles all have the same measure. Is that always true? It turns out it is. Vertical angles are supplementary. They form a straight line and their measures sum up to 180 to the same angle. The only way that both of these angles can be supplementary to the same angle 150 is if they're both equal to 30 degrees. Let's take some time to add this fact about vertical angles in your notes. Let's try one more example. I'm going to post two diagrams. Your job is to find as many pairs of vertical angles as you can find in each diagram. Let's take some time to find the vertical angles. You don't need to redraw the diagrams, but try to write down the names of the sets of vertical angles if you can. Let's come back together. Did you find all the sets of vertical angles? Remember, vertical angles are formed when two lines intersect and form four angles. In the second example here, the segment through K and J doesn't go all the way through to form more angles, so there are no vertical angles formed. The tricky part is seeing that angle HJG and angle FJI are vertical angles, even though the extra segment through K makes it look more complicated. As we wrap up our time today, let's revisit two big ideas. The first is that angles do not have to be adjacent to each other to be complementary or supplementary. To be complementary, the measures of the angles have to sum up to 90 degrees, and to be supplementary, the measures of the angles have to add up to 180 degrees, regardless of whether they're adjacent or not. The second big idea also involves non-adjacent angles that are also very special. These are called vertical angles. Vertical angles are the angles across the intersection from each other when two lines cross. They are always congruent because they are supplementary to the same angle. Before next time, let's see if you could put these new definitions to work. The question asks you to find the values of B and C, but I would like to further challenge you to see what vocabulary words you might use if you were explaining this problem to a friend who was absent today. Let's take some time to copy the problem in your notebook or take a picture with your phone. I can't wait to see what you guys come up with.
Practice aligned to the learning from today's episode can be found here.
The Illustrative Mathematics Video Learning Series is a joint production of Louisiana Public Broadcasting, the Louisiana Department of Education, and School Kit, made possible by a grant from the Bill and Melinda Gates Foundation and the Charles and Lynn Schusterman Family Foundation.